Okay, last topic of Unit 4, watersheds. Now, a watershed is not a place where you keep water. A watershed basically means an area of land where all the water that lands in that area is going to drain out of one common outflow point, or what we call discharge point. That would include surface water, like runoff and streams, but also it includes groundwater. So this is a good diagram. So here is a watershed, and what that means is all the rain that falls, all the water in this area here is going to drain out through this river at this point here. So all the water that is shed in this area, whether it's surface water, surface runoff, rivers, or groundwater, is all going to drain out of this one place. So it's a very important thing from an environmental standpoint because by delineating a watershed, we can make predictions about where pollution will and will not end up, depending on where it's released from. So a watershed can be a very small thing. It can be just a few hectares. It can be just one little stream area. It could be something the size of the KS campus, or it could be something as large as the Amazon River Basin or the Mississippi. So it can be continental in size. We choose what area of land we're going to look at, but watersheds definitely have very specific geographic boundaries that we can't arbitrarily choose. We can choose which watersheds to congregate to call a larger watershed, but we can't really choose what boundaries there are for a given watershed. So at the uppermost part of a watershed, we call it the headwaters, and the headwaters tend to be on ridge lines. And in alpine areas, there's often snow in the wintertime, so there's snow melt that takes place up there. But we'll get runoff from rain, we'll get springs and snow melt. That basically is where the water first comes from. Now, that's where it starts its downhill journey. A divide is a very important concept. A divide is the boundary between one watershed and the next, and these typically happen at ridgelines or hilltops. So let's just take a look at this. So in looking at this here, I see that water is going to be draining out this way through this stream system. Here's a ridgeline here, and so any water falling here is going to drain down this stream here, join this stream, and then flow down this way off the map this way. Water falling here is going to drain into that same system. So it's part of the same watershed. But water that lands over here is going to drain down this stream over this way and not join this stream. So this land over here is part of a different shed. Water over here sheds in a different direction. So the boundary between this watershed and this watershed is called a divide. And a divide typically is going to be a ridge line. So here's the divide between these watersheds. Now, if you look here, this is a divide here because water landing here will shed down into this stream, where water landing on this side of that ridgeline will drain out into this one here. Now, the lower end of a watershed is often called the outflow point or the discharge point. And so basically all the water that lands in that area, whether it goes into the ground or not, is going to come out in this point right here. So basically, all the water that comes into this watershed will come out of this point, as will any pollutants that are picked up by that watershed. So pollution tends to become aggregated or accumulated as it moves from the headwaters down to the outflow point. And so contamination that's introduced at one part of a watershed will affect the points of the watershed downstream from it, but it will not affect the ones that are upstream from it. So by defining a watershed in terms of the area extent of it and the topographic areas of it, in other words, what are the high ground, what are the low ground, it lets us predict where we can expect for the water to, the pollution to move. Okay, so let's just see if we can figure out where the divide for this particular watershed is. Now, this is what's known as a contour map or a topographic map. And the idea is we see lines of equal elevation. So if I was to walk along this dark line here, wherever I walk, I'm at an elevation of 6,600 feet, I would imagine, probably not meters. And so as long as I stay on this line, I'm always at the same elevation. So it connects points of equal elevation. And by doing this, it defines what we call the contours of the land. It helps me see how the land is laid out in terms of elevation. And you'll notice that anytime these contour lines cross a stream, they tend to point upstream. Here's the headwaters of the stream. If you notice, as these contour lines reach the stream, they tend to point up. And that's because it's cutting into the hillside. So to stay at equal elevation, I'd have to walk up the stream valley a little bit. And so we can look at these contour lines and see the flow of water. We can see that the water is coming from the area that these are pointing up towards, so the water is flowing the opposite direction. So the water is flowing this way on this map. So if I look here, this creek here, it flows this way. This creek here flows this way. It's joined by this one, which is flowing this way. So all of them have this common outflow point here, all right, this discharge point. But but where is the boundaries of this? So water landing here is going to flow downhill and go here. Water landing here is going to flow downhill and go here. But water that lands, say, here is going to flow into this stream over here. So the divide is going to be the ridge line between this watershed here and the other one. So here's how I think it would look. I'm going to stay on the ridge line here. So this is where the boundary would be. It would come up this way. It would go here. It'd follow this ridge line this way. And then I would come over to here, and I'd come down this one here. And now I'd come down this one here. And that is going to be the boundaries of this watershed, the divide between this watershed and the next. So water landing on this side of that red line is going to flow into this watershed and pass through this discharge point. But water landing outside of this area is going to shed to a different watershed and flow through a different discharge point. So the characteristics of a watershed include the following: the area that it has, the bigger the area, the length of it, which is obviously related to area, the slope of it, so how much change is there in topography, the type of soil that's present in it, and also the type of vegetation that's present. All of these are going to affect the characteristic of a watershed. So let's start with area. So obviously, the more area it has, the more water it can collect because there's a bigger region to pick up. So let's just say you get 1 centimeter of rain falls in this area. Well, the bigger the area is, the more centimeters of water you collect, the more that pass out this way through its discharge point. Length. Well, the longer a watershed is, the more water it can accumulate, and therefore the more water that comes out at its discharge point. So the now one thing is the longer it is can determine how much time the water will stay within that watershed. So a longer watershed may, as long as it's not too steep, will give more time for water to flow. So for instance, it takes about 90 days to water to flow from the headwaters in the mountains of, say, the Rockies through the outflow into the Gulf of Mexico because it's so long. But in other ones, like the one I just looked at before, this one here, it might take, like less than an hour. Slope or gradient of it. So the steeper watershed is, the faster the water is going to move, and fast moving water tends to erode and carry larger particles with it. So a steep watershed tends to be one that causes a lot of erosion, but a gentle one is one that causes deposition. So if we go back to this one here, this is very steep. So this is going to be eroding and cutting into the mountainside and carrying materials away through the outflow point through erosion and transportation. But when we get to ones like this, we're going to find in this region here, they're calling the riparian zone, this is where we're going to be depositing. So the upper headwaters, we tend to erode because it's steep, and we tend to deposit the materials as silt out and sand out here in the river, the wider river valleys where it's flowing more slowly. Soil. So basically, sandy soils are less likely to have runoff because they are easier they have bigger pores, more permeability, so water can seep into it better, but they're also more easily eroded. Clay-rich soils prevent infiltration from happening, so there's not as much permeability, so water tends to flow across the land and into the drainages. Uh, Now, in low gradient regions, what we find is watersheds tend to have deep, silty, nutrient-rich soils. So basically, along slow-moving rivers, we have these floodplains where this silt is deposited, and it tends to make very great soil for agricultural purposes. And then we have vegetation. So plants, in particular trees, are good at reducing the rate of runoff. So if we have a lot of vegetation in our watershed, we expect to have less runoff and therefore less flooding, less erosion happening. Also, the decaying plant matter, especially from deciduous ones that drop their leaves, that puts a lot of nutrient into it. And if you remember, I think it was like one of the first days of the year, we talked about the nutrient levels. As we move down a stream, the nutrient levels increase because more and more trees are adding their nutrient load to the stream. And what we find is if we remove trees from a watershed, especially on the upper parts of it near the headwaters, we tend to cause a lot of problem for the whole watershed because there's going to be increased erosion, which means increased there's going to be flooding, and that means we're going to be transporting a lot of sediment down farther into the watershed and affecting all the points from the headwaters down through the discharge point. Okay, well, that's it for watersheds. That's it for Unit 4. We're moving through this year just as fast as we're supposed to. We're staying on target. Good for us.